Okay, children, so today we will discuss Ohm's law. Okay, children, so what is Ohm's law? Ohm's law states that potential applied is directly proportional to current flowing in a conductor. Current flowing in a conductor. Potential applied is directly proportional to current flowing in a conductor. Means you will put a battery, the current will flow. You will put a battery, the current will flow. How much potential you apply, that much current. If you put a small battery, very less current will flow. If you put a big battery, so much current will flow because big battery will, so many batteries will give so much potential difference. How much potential difference you apply, that much current will flow. So velocity is there. Sorry. Uh, Potential applied is directly proportional to current flowing. Removing proportionality, you have to keep a constant R, where R is called resistance. So V is equal to IR is the formula for Ohm's law. Okay, and if you plot a graph between V and I, you will get a straight line passing through the origin. The straight line gives resistance because V by I is R. This straight line which is passing through the origin is called slope. They will give slope of VI graph. Slope of VI graph gives what? Resistance. Slope of VI graph gives resistance. In mathematics coordinate geometry, you know slope is represented by M. Okay, and slope formula is tan theta. M is equal to tan theta. Another formula for slope is y2 minus y1 by x2 minus x1. That is also formula. And here resistance formula, we can take either M, we can take tan theta, y2 minus, or you can take V by I. Anything we can use. Anything you can use. Your wish, no problem. According to the question. Okay. Now, the substances which obey Ohm's law are called ohmic conductors. The substances which obey Ohm's law are called ohmic conductors, and which do not obey Ohm's law are called non-ohmic conductors. Sometimes they will ask question like this also. They will give a graph V or I. V here, I here also I can keep children. There is no hard and fast rule that I should keep like this only. Two graphs they will give children. This is A, this is B. Okay, and they will ask you question which is having more resistance among A and B, which is having more resistance. So children, remember easy method. I would say whichever graph is nearer to B, that will have more resistance. So A will have more resistance. But remember children, more resistance means length is also more because resistance is directly proportional to length of the conductor, which is not there in our syllabus, just entering. And which is among A and B, which is having more length means A only more length, because whichever is having more resistance, that will have more length. And which is having less area means A will have less area, children. Less area, because resistance is inversely proportional to area. And which among them are connected in series means A is connected in series, children, because in series resistance is more always. In series resistance is more. And which is having among them, which is very hot, they will say. So you should say A is having more temperature, because if resistance is more, obstruction will be more. If obstruction is more, temperature will be more. If obstruction is more, temperature will be more. Okay, so like this, different questions they can ask children. And all opposite statements are true for B. It will be having less resistance, it will have less length, it will have more area, it can have more area, it is connected in parallel, and it will have less temperature. Okay, if V is given, so whichever graph is nearer to V, that will have more resistance. Whichever graph is nearer to V, that will have more resistance. Sometimes to confuse you, they may give V here, they may give I here. That time V will have more resistance. You should not get confused. Okay, children? So this is which is they will give two graphs and they'll ask which is having more resistance. Whichever is nearer to V, that will have more resistance, and that will have more length, that will have less area, that is connected in series, that will have more temperature, like this. Okay, now we have one Ohm's law experiment also. How do we do Ohm's law experiment activity? In class, how we will do Ohm's law activity? So children, what you have to do is Ohm's law activity, you have to find out resistance of an unknown wire. You have to find out resistance of an unknown wire. How will you do? How will you do, Miss children? You will take battery, you will take plug key, and you will take a rheostat. You will take a rheostat. Children, rheostat is written like this. What is rheostat means? Which is used to alter the current. It's like a regulator in our fan. This is rheostat symbol. Rheostat is used to alter the current. Means how much current you want, that much you can set. Rheostat is used to alter the current. Rheostat is used to alter the current. And this is plus, this is minus. And connect one ammeter, children. Ammeter measures current. Here plus is there, so put here plus. Here minus is there, so put here minus. Across this R also put one voltmeter in parallel, because voltmeter is always connected in parallel. Remember, voltmeter is always connected in parallel, ammeter is connected in series. Here plus is there, so put here plus. Here minus is there, so put here minus. This is the apparatus used in Ohm's law activity in our class. What is the aim? What is the aim of Ohm's law activity? To find out unknown R. What is the aim of this activity? To find out unknown R. So how we will do this activity means current, potential, resistance. Children, this is rheostat is in your hands. How much current you want, that much current you can send. Suppose, say I am sending 2 amperes of current. How you will know, sir? Means ammeter is there, no? Ammeter is there, it will show 2 amperes. When 2 amperes of current you are sending, what is the potential reading you have to count? Let me say 10 volt. You should take down, note down. This you are sending, this you are noting down. This you are sending using rheostat, this you are sending, this you will see from here. Now let me say 3 amperes I am sending next, in next step. We have to do 3-4 times children activity so that to prevent any experimental errors. When 3 amperes, let me say it is 30 volts current is coming. So 50 volts potential is recorded here. How much current you are sending means that is depends upon rheostat children, and how much current you want to send, that will be recorded in ammeter. And ammeter recording, this is according to your wish, you are sending the current. When you are sending the current, how much is the voltmeter reading you will take from here. Now let me say 4 amperes you are sending. At that time, imagine potential is 20 volts. Now let me say 5 amperes you are sending, so let me say 25 volt. Now why you are doing so many times, sir? You will ask. We will do experiment anything 3-4 times we will do, children, to prevent any experimental errors. To prevent any experimental errors. Now, how we will do this activity means, see Nana, you will send the current of 5 amp. Nana, if you didn't understand, you can tell Nana, no problem. You can speak in the middle. If recording is there also, no problem. You can speak in the middle. This
Okay,
current,
sir.
this current you are sending, is it okay, na? This current you are sending. How we are sending? By using rheostat, you can change, you can increase, you can decrease. It is like a regulator in our fan. 1 number fan, 2 number fan, 3 number fan, 4 number fan, 5 number fan. How you will change? In rheostat also buttons will be there. By using the buttons, you can change the current. Okay, na?
Yeah, sir, got that.
How much current you want, you can send. And when your current is your wish, current is your wish. Current sending is your wish. But when you are sending your wish current, how much potential is coming here, you should note down. Current, what you are sending is your wish. But potential you have to note down here. From here you should note down.
Yeah, sir.
So once you will send 2, once you will send 3, once you will send 4, once you will send 5. In each case, find resistance R is equal to V by A. How much am I? 10 by 2, how much? 5 ohms. 15 by 3, how much am I? 5 ohms. 20 by 4, how much? 5 ohms. 25 by 5, 5 ohms. How many times we did? 4 times. 20. 20 by 4, again you got 5 ohms is the answer.
Okay,
So
sir, now got it.
the average resistance of the after doing so many times experiment, 4 or 5 times I got average 5 ampere, 5 ohms. So the value of this resistor wire is 5 ohms. This is Ohm's law activity, and if ever for this activity, if you draw a graph for this activity, if you draw a graph, okay, here we here I. Okay, I is 2, 3, 4, 5, 10, 15, 20, 25. Okay, here one dot, here one dot. You will get straight line passing through. Compulsory you will get straight line. Now, why you will get straight line? Because Resistance is constant. Why you get straight line? Because resistance is constant. Resistance was constant. No, we kept it removing proportionality. We kept a resistance constant. That's why you get resistance constant. Compulsory, you get resistance constant here. Okay. Now, what are ohmic conductors and what are non-ohmic conductors? I told you first of children, ohmic conductors are those conductors which obey Ohm's law, and non-ohmic conductors are those which do not obey Ohm's law. Ohmic and non-ohmic conductors differences. Ohmic and non-ohmic conductors differences. First one, what is the children? Here, Ohm's law is constant. Ohm's law is obeys Ohm's law, so V by I is constant. Here they do not obey Ohm's law, so V by I is not constant. Here they obey, and here they do not obey. Here the graph is straight line. You get like this straight line, children. For ohmic conductors, you'll get a straight line. And here you will not get not straight line. You will not get a straight line because they are not obeying Ohm's law, children. And here slope of VA graph is same at all values. Means it is a constant, but children, slope will be always it is constant. Slope will be constant. Here slope won't be constant because it is coming like a wavy graph, no children. So slope won't be constant. It won't be constant. And here most of the metals are examples of ohmic conductors. Most of the metals because they obey. And here children, junction diode, LED, transistors, filament, bulb are example of non-ohmic conductors. What are the examples of non-ohmic conductors? Diode, LED, transistor, filament, etc. These are the examples of non-ohmic. And most of the metals are examples of ohmic conductors. Children. For non-ohmic conductors, it won't be straight line, children. It will be like this or somewhat like this. Children. Okay, so this is about ohmic and non-ohmic conductors. Now, basing on Ohm's law, we'll do some numericals. Basing on Ohm's law, we'll do some numericals. Chalo, we'll do some numericals. First question. Okay. So this is first question. If you know, you can tell. So the calculate the potential difference required across a conductor of resistance 5 ohms to pass a current of 1.5 amperes. Okay, children, what is the formula for Ohm's law, children? V is equal to IR. V is equal to 5 into 1.5. If you know, you can tell, no problem. 7.5 volts is the answer. Don't sit idle like that. You will forget everything. Second question. Girls, second question. If you know, you can tell.
Yes, sir.
An electric gadget draws a current of 200 milliamperes. Milli means you should 2 by 1000 children. Okay, from a battery of 12 volts. From a battery of 12 volts. Find the resistance. Anyone wants to say?
It's V by I, right, sir?
V is equal to IR. Okay. 12 is equal to, tell me, I is how much? 200 by 1000 into R. Milli means by 1000 you should do. Milli means by 1000 you should do this. So this gone, 2 5s are 12 5s are 60 ohms. Some more questions. I'm doing from your textbook only, children. Please see here. So a torch bulb, when cold, has a resistance of 1 ohm. Okay, and it draws a current of 300 milliamperes when glowing from a source of potential difference 3 volt. 3 volt. Calculate the resistance of bulb when glowing and explain the reason. So calculate the resistance of bulb when it is glowing. Calculate the resistance of bulb when it is glowing. So children, V is equal to IR. So 3 volts it is connected. I is how much, children? I is how much? 300 milli. Milli means what we should do this? By 1000 into R. This and this is gone. This and this is gone. 10 will go here. Answer is 10 ohms when it is glowing. Actually 1 ohm when it is not glowing. 10 ohms when it is glowing. Okay. Okay, children? So why is the difference when it is not glowing 1 ohm, when it is glowing 10 ohms? Why is this difference occurring? Means because When you pass the current, the temperature increases. When you pass the current, temperature increases and resistance increases. When you pass current, resistance increases and temperature increases. Okay, guys, next one. Next one question is like this. Um, yeah, next question. If you know, you can tell children. So find the potential difference required to flow a current of 200 milliamperes in a wire of resistance 20 ohms. Varsha, tell me how to do this. V is equal to IR. Current is 200 milliamps by 1000 into 20.
Into 20.
This is gone. So 2 to the 4 volt. Direct sums also you are not telling or not. An electric bulb draws 1.2 amperes of current from a 6 volt potential. Find the resistance. Find the resistance. Satvika, can you tell how to do this?
Sir,
Tell. V is how
yeah,
much?
so R equal to I by V.
6C is equal to 1.2 into R. Tell Nana, you are not telling R is equal to 6 by 1.2. So remove this point, you get 0. 60 by 12. How much is that? 5 ohms. Direct question I am getting from the 10 numeracy. Next, Alekya, you tell this one. A car bulb connected to a 12 volt battery draws a current of 2 amperes. What is the resistance? What is the resistance? Alekya. My goodness, you people. 12 is equal to 2 into R. This goes down. 12 by 2 is 6
12 by
ohms.
2, yeah.
6.
Sir,
Next
can you
question.
hear us, sir?
Huh? What happened?
Can you hear us?
No, I'm not able to hear. Now we are telling. Now
Yes,
we are
sir.
able
I
to.
mean, Sathika did answer, sir. I guess you couldn't hear her.
Okay. Next one. Question is there. One application type of question is there. I will write down on the board. I will write on the board. So potential current. If potential is zero point 0.5, current is 0.2 amperes. If potential is 1, current is 0.4. If potential is 1.5, current is 0.6. If potential is 2 volt, current is 0.8 amperes. If potential is 2.5 volt, current is 1 ampere. This is the table they have given. This is your textbook problem solving. This is in volts, this is in amperes. This is in the experiment. They got the following observation. First question is draw the graph. Draw the graph. So children, you can take your own scale and you can draw the graph. Don't expect them to give graph papers, okay? In exam, they won't give graph papers. Just you have to take your own scale and you have to draw 1, 1.5, 2. So zero point 0.5 is 0 0.2 is 0.2.
Yeah, sir.
0.4 is 1. This is 1.5 is 0.6. 2 is 0.8. 2.5 is 1. So you get a straight line. Show that you get a straight line. That's it. You will get a straight line because resistance is constant. Now the
Yeah,
questions.
sir.
First question is based on this. Find potential difference. Find potential difference when current is zero point 0.5 amperes. So for that thing, for this question to answer, first you have to find resistance in this. First you have to find resistance. In this graph, first you have to find resistance. Can anyone tell how to find resistance? Resistance is equal to V by I. Okay, so zero point 0.5 by zero point 0.2. That is 5 by 2. That is how much? 2.5 ohms. Resistance all 2.5 only because constant, no children. So
Yeah.
now resistance is 2.5. Resistance is 2.5. Over, you got it. Resistance is 2.5. You got from graph. He's asking potential and current is zero point 0.5. So V is equal to IR
IR
0.5 to
0.5 into 2.5.
1.25 volt. So this is first question. Second question, what they are asking is, find the current. Find the current when potential is 0.75 volts. And how much is the resistance you calculated? 2.5 ohms. Now he want current when potential is 0.7. What is the formula for I? I is equal to V by R.
V by R.
Okay, so 0.7 by 2.5. So
0.5.
7 by 25, that is 0.28 amperes. This is second question. What is the resistance of the circuit? 2.5. Third one is, what is the resistance of circuit? Anyway, you calculate it will be 2.5 over children because it is constant. Okay, children, so all the questions which are possible in your textbook, I told you, children. All the possible questions I told you. So they
Okay,
gave
sir.
children, they gave one graph. One is like this, one is like this. He's asking A and B, which is ohmic and which is non-ohmic. He's asking. What do you say, children?
Sir, the straight line is constant, so it's ohmic resistor.
And this is non-ohmic conductor. Like this, they are asking questions. Girls, this is about Ohm's law, and you have to do some more numericals if it is possible from other books. In your textbook, whatever they have given, I told you, children. And please go to Ohm's law because in electricity, as per my knowledge, only Ohm's law is there. Once you ask your teacher also.